Okay, so how do we find the derivative of a product of two functions, here f of x and g of x? Well, let's remind ourselves of what the limit definition of the derivative is first. If we were trying to find the derivative of just f, then that would be the limit as h goes to 0 of f of x plus h minus f of x, all of that over h. So it looks like I'm going to have to plug in an input of x plus h into my expression. In this case, the product of these two functions. I'll have to plug in an x and subtract them and put it all over h inside of a limit. Okay, so let's go ahead and do that. Okay, so here we go. And notice again, I've plugged in x plus h right here and here. Okay, plugging that in there, and I've duplicated the function I'm taking the derivative of here. And of course it's over h, and I'm taking a limit as h goes to 0. Now what? I don't know anything about f or g. I hope that the derivatives of f and g both exist. In other words, I hope this limit right here does indeed exist, and this limit right here also exists, presumably, the derivative of g. But how does that help me advance this any? Well, wouldn't it be nice if we could see the derivative of f, or maybe even the derivative of g, or both, show up down here? We've got the basic pieces. Look, we've got an f of x plus h here. There's an f of x plus h. I've got a g of x plus h here. There's a g of x plus h. There's an f of x and a g of x. It looks like all the pieces are here. So here's what we can do. We can try to manufacture this expression within this expression so that in the limit we will have a piece of this representing the derivative of f, and see where that leads. Okay, so I've got an f of x plus h. I would really like to have immediately following it a minus f of x. I don't really want to see this g of x plus h here. So let's insert what we want and then just compensate for the insertion. So I'm going to insert right after this f of x plus h a minus f of x. And notice this is wrapped in parentheses because all of it is getting multiplied by g of x plus h. Now, how do I compensate for that insertion? Because certainly if I just do that, I have changed this expression. Well, how have I changed the numerator in particular? If I were to expand this all out, what's different? I still have f of x plus h times g of x plus h. There's that. But then I also have this product, minus f of x times g of x plus h. So I have this additional negative term right here. I'm going to have to add that term right back in to compensate for this guy's insertion. Okay, so here we go. We've added it back in, f of x times g of x plus h. Hence the space there that I left for that compensating term. But now do you see, I could break this fraction apart, putting the different terms over h. I could put this whole term over h, and I could put this whole term over h and add the two resulting fractions, and that's going to get this f of x plus h minus f of x over an h, which is exactly this expression right here. Let's take a look. Okay, so now you can see these last two terms right here over h, that shows up in purple, and then we have this term over h showing up here in green and black, and what I've done is I've just kind of pushed the h over so it sits only under the f of x plus h minus f of x term, since that was what I was trying to manufacture right here. Okay? Now, what about this purple term? Well, if we just follow our natural instincts here, look at the numerator. We have f of x times this minus f of x times that. Aren't you just inclined to pull out that common f of x? Look what happens when you do so. There, we've pulled out a common blue f of x here. Look what's left. G of x plus h minus g of x over h. Does that look familiar? You bet it does. In the limit as h goes to 0, that's the derivative of g. Okay, so let's take a look at all these different pieces. It looks like this, in the limit, is going to turn into the derivative of f, it looks like this in the limit is going to turn into the derivative of g. This in the limit, as h goes to 0, notice there's no h in this expression, is simply going to be f of x. And what do you think this is going to do in the limit as h goes to 0? Will we be able to simply plug in 0 and get g of x? That would give us f prime of x times g of x plus f of x times g prime of x. Wouldn't that be wonderful? That would be nice, but let's make sure our intuition agrees with reality. Let's take a look back at this limit definition for the derivative of g. If we are going to presume that both of these derivatives exist, and hence both limits exist, if this limit exists, think about what that means for the limit of the numerator and the limit of the denominator as h goes to 0. Certainly the limit of just the denominator as h goes to 0 is 0. So we have a 0 sitting in the denominator in terms of a limiting value. What does that mean for the numerator's limiting value? Look, if I put any other number up here, like 2, let's say the limiting value of the numerator was 2 or 3 or negative 5 billion or negative pi, anything besides 0, then we would have a problem, wouldn't we? This limit would not exist. We'd have some sort of vertical asymptote involved. The only way for this overall limit to exist, given that the limiting value of the denominator is 0, the only way this entire limit can exist is if the numerator also has a limiting value of 0. Okay? So, what does that mean? So going down here, if the derivative of g does indeed exist, right, this whole limit, then the limit of the numerator, g of x plus h minus g of x, as h goes to 0, that must be 0. But remember, a limit of a difference is a difference of limits. So, the limit of the first term minus the limit of the second term must also be 0. But then look at this second limit here. The limit as h goes to 0 of g of x. There's no h here. This has got to be just g of x. And if I take it to the other side, notice what that gives me. The limit as h goes to 0 of g of x plus h equals g of x. So I am free to replace this with this. This guy right here guarantees that that's okay to write. Okay? So now we have an expression for the derivative of the product in terms of the product of two functions in terms of those original functions and their derivatives. So summing up, the derivative of the product of f of x and g of x is the derivative of f times g of x plus f of x times the derivative of g of x. QED. We have proven what we wanted to prove. That's it.